This video is for class 9 physics and today's topic is upthrust is equal to the weight of the displaced liquid. So today we are doing some mathematical proof, right? And we are proving that upthrust, whatever we have studied, is equal to the weight of the displaced liquid. When a body is immersed in a liquid, upthrust on it due to the liquid is equal to the weight of the liquid displaced by the submerged part of the body. So to understand this, we have come to the blank page. Suppose we have a container, right? Suppose we fill this container with a liquid till its brim, right? And we try to insert one object, right, inside it. So when the object is inserted inside the container, suppose the object comes here. Now what will happen is the water will spill out, or the liquid will spill out. When the spilled liquid is collected in another container, suppose when the spilled liquid is collected in another container, suppose in this container here, right? Suppose the spilled liquid comes, okay, the spilled liquid comes and we are collecting it in this container, right? So as you all know, this object will be experiencing some upthrust, which is a force. That upthrust, whatever it is experiencing right now, should be equal to the weight of the liquid displaced. Right? So this liquid here, if I can find the weight of this liquid, that will give me the value of the upthrust. Now the question comes, how? That we are about to prove. I hope you understood the concept. Okay, let us try to understand the proof now. To prove that upthrust should be equal to the weight of the liquid displaced, let us consider a cylindrical body PQRS, as shown here, PQRS, right? A cylindrical body PQRS, like this here. Okay, so it is PQRS, like we have proved for the pressure. Okay, now having the cross-sectional area A immersed in the liquid of density rho as shown in the figure 5.4, let the upper surface PQ of a body be at a depth h1 while its lower surface RS be at a depth h2 below the surface of the liquid. Okay, so it is fully immersed here. As you can see, the area of this surface and the area of this surface is equal, and you know the reason for the upthrust also. The pressure P2 is more than pressure P1. Yes, we had done this in the previous video, reason for upthrust. So it's kind of a similar kind of condition here. So H1 is exerting pressure P1, okay, on the surface A at the upper surface, and the water column H2 is exerting pressure P2 on the surface A at the lower face. Okay, I hope you understood the scenario. Now at the depth H1, pressure on the upper surface PQ is P1 equals to H1 rho g here. If you can see here, the pressure P1 should be equal to H1 rho is the density of the liquid, and g stands for acceleration due to gravity. So this was the formula for pressure, H rho g. So here the pressure here is supposed to be this much, right? And the pressure here supposed to be H2 rho g, right? I can't write H rho 2 because the liquid is same. I hope you understood the scenario. right? So which pressure should be more? Obviously P2 should be more. Now, so the downward thrust on the upper surface, F1 should be equals to pressure into area. So here again we are going to the figure. So this F1 here, right? So this F1 here should be equal to pressure P1 multiplied by the area on which it is acting. Now just now we know the what do you say, the expression for the pressure, which is H1 rho g. So F1 should be equal to pressure's expression H1 rho g, right, multiplied by area, which was taken to be A. Let this be equation number 1. I hope you have understood till here. Okay, now at depth H2, pressure on the lower surface RS should be P2 equals to H2 rho g, which I have shown you just before, right, this whole explanation. Now upward thrust on the lower surface RS should be F2, right, and F2's value should be pressure, that is P2 multiplied by A. So P2's value is S2 rho g, right, P2's value is S2 rho g multiplied by A is the area. Okay, so here ultimately what we have discussed is this F1, the value of F1 is P1 multiplied by area, which is H1 rho g A, right, and F2's value should be P2 multiplied by the area, which should be again equal to H2 rho g A, right. This rho g A and rho g A are same. Okay, I hope you understood. This is same thing which we were doing in the region for upthrust. Now, since we have formulated the values of force F1 and F2, the horizontal thrust at various points on the vertical sides of the body gets balanced, because liquid pressure is same at all the points at the same depth. It means that if there is any force acting on this surface laterally, should be cancelled, because the value of the pressure is same at the same depth. Okay, right. So after knowing this concept, now from the equations 1 and 2, that is F1 equals to H1 rho g, that is this here, F1 equals to H1 rho g and F2 equals to H2 rho g, what we can conclude is clearly we can say F2 is more than F1 because H2 is more than H1, and therefore the body will experience a net upward force. That was the reason for upthrust, right? Now, resultant upthrust or the buoyant force on the body should be F2 minus F1, right? The buoyant force should be F2 minus F1. Okay, now this was also proved in the previous video actually, right? Only the values were not calculated. Okay, now F2's value is H2 rho GA, right, and F1's value is H1 rho GA, which I have just seen, right. Now from this expression what you can see is the common thing here is rho GA and rho GA, right. The common thing here is rho GA and rho GA, so they can be taken out common. So rho G has been written at the back and A has been written at the front. It's same thing actually. We could have written H2 minus H1 and then we could have written rho GA. Okay, A rho G. We could have written this also. It means same, right? But they have written this in this fashion for a certain reason. Okay, now but A multiplied by H2 minus H1, that is area multiplied by the length or the height. Okay, length or the height should be equal to volume, isn't it? Should be equal to volume. Now should be equals to V, the volume of the body submerged in the liquid. This volume is the volume of the body that is submerged, that is put inside the liquid, not the whole volume of the liquid, right? Thus the value of the upthrust, which is Fb, should be equal to V rho G, because this much becomes V, and rho g is left. So upthrust becomes Fb equals to V rho g. Now, since a solid when immersed in a liquid displaces equal liquid to the volume of its submerged part, therefore, okay, explaining this particular line here, okay, suppose I take an object, of volume 20 centimeter cube and I fully immersed in the liquid. How much liquid will it displace? Obviously 20 centimeter cube. Suppose I take 50, then 50, right? So the volume immersed, right, since the solid when immersed in the liquid, the volume of the immersed part or the submerged part should be equal to the volume of the liquid displaced, right? Now V rho g should be equal to volume of the solid immersed, which you have studied, multiplied by the density of the liquid multiplied by acceleration due to gravity. Now this also can be changed. This particular word can be changed into volume of the liquid displaced. Volume of the liquid displaced, because they are same. Okay, let's see. So, or here you can see V rho g is equal to volume of the liquid displaced, because the volume of the solid immersed and the volume of the liquid displaced is same, multiplied by density of a liquid and acceleration due to gravity. Now volume multiplied by density, from the formula D equals, which I done in class 7, if you remember, mass upon volume, right? Mass can be written as density multiplied by volume. This is the old one. I'm using D here, right? But if I want to standardize it, then I can say density should be equals to mass by volume. Therefore mass should be equal to density multiplied by volume, right? Okay, so now here you can see volume multiplied by density here should be equal to mass. So therefore they have written mass of the liquid displaced multiplied by acceleration due to gravity, that is mass multiplied by A. This is quite familiar to you from chapter number 3, that is force. So force should be equals to mass into acceleration, right? That equals to weight of the liquid displaced by the submerged part of the body, because force equals to ma. Now this was the formula for the force, but here we are writing mass into acceleration due to gravity. This was the formula for weight, if you remember, right? So this here mass, that is m multiplied by g, should be weight of the liquid displaced by the submerged part of the body. Thus we have proved that upthrust is equal to the weight of the liquid displaced by the submerged part of the body, right? I hope you have understood till here. Now note, if a body is completely immersed in a liquid, the volume of a liquid displaced will be equal to its own volume, right? If whole thing is immersed, then the whole volume should be equal to the volume of the liquid displaced, and the upthrust then will be Fb dash, if you remember, right? If the whole thing is immersed, the whole body is immersed, then the upthrust will be maximum, which is Fb dash. Although the above result is derived for a cylindrical body, but it is equally true for a body of any shape and size, right?